All right, guys, so this is the last one I'm going to do for tonight. This is question number 40 from the Openstax textbook. All right, talking about the world record for Usain Bolt. Now, this is going to combine some ideas from 6 and 7 from the homework. All right, from the notes packet. But again, I'm going to try to work through it and show you a process and a problem solving, a way to approach the problem to hopefully make the question a little bit easier. So you can obviously read the question, pause it and read it if you need to. All right, so in situation 1, we've got Usain Bolt who's doing the 100-meter dash. Okay, now that tells me something right off the bat. I know that if I start with an initial position of 0, that my final position is going to be 100 meters. All right, so that's for the whole thing. Okay, Bolt coasted across the finish line with a time. So the total time, so this is all the total information, right? The total time is going to be 9.69 seconds. If we assume that Bolt accelerated for 3 seconds, okay, so this is giving us a different piece of information, right? This is giving us a phase of acceleration, right? So it's saying that for some of the time, he's going to accelerate, and the time of acceleration is 3.00 seconds, right, to get up to his maximum speed, whatever that is. We're assuming that he's starting at rest, right, and he's going to get up to his maximum speed there, and that acceleration, of course, is constant. And he maintains that speed for the rest of the race, right? So he's got the acceleration phase, and then he's got the coasting phase, right? And in the coasting phase, his initial velocity is going to be whatever v was down there, right? That's also going to be his final velocity there, right? Still that same v, all right? Now, what is the time going to be? Well, the time of the coasting phase, it said that his total time was 9.69 seconds. 3 of it was accelerating, which means the time for the coasting is 9.69 minus 3, which is going to be 6.69 seconds, right? We know that the total distance is going to be 100 meters, right? So whatever we get here, okay, that's going to be some x. This final displacement needs to be 100 minus x, right? That's how far he needs to travel in this 6.69 seconds. All right, so we've got a whole bunch of information given here. We also know that during the coasting phase, the acceleration is 0, right? Whereas in the acceleration phase, we don't know what it is. So we actually have quite a bit of information. Even though we feel like there's not a lot there, there's actually a significant amount of information there, right? Now, our goal is hopefully to be able to put all these things together and be able to, kind of answer this question, right? So I'm going to see if I can write an equation with the information that's given to me, right? So I'm going to do one for the acceleration phase. Notice that I'm going to use the time, the initial velocity, the final velocity, which is going to be v, and the displacement, which is x. And yes, there's 2 variables there, but this velocity is going to be the same as the one that I use over here in the coasting phase. This displacement is going to be the same one that I use right there in the coasting phase. It's going to be the same x, right? Whatever x he covers here, he doesn't need to cover here. It's 100 minus that, right? So I just need a couple of equations now that are going to relate those 2 things. No other variables, right? I don't want any other variables other than these, right? Because I got x and v. Those are my 2 variables. So I don't really want to include anything else. So I'm looking at my equations, right? I've got the 3. I've got the v equals v naught plus at. I've got the x equals x naught plus v naught t plus 1/2 at squared. And of course, I'm not putting all the x's down there because I know this is all in the same component, the same direction. Final velocity equals initial velocity plus 2ax minus x naught. Okay, so I'm looking at my acceleration phase. I don't really want to use this guy right here, right? Because that's got acceleration, and I don't want to bring acceleration up. I know that I'm considering acceleration to be constant there. Okay, this one right here also uses acceleration, so I want to try to avoid that if I can. Unfortunately, look at this. The last guy also uses acceleration. So what in the world am I supposed to do? Well, I'm obviously going to have to use that acceleration, right? That means I'm actually going to have 3 different equations, all right? So, or you could use the definition of acceleration, right? We know that the definition of acceleration is that acceleration is the final velocity minus the initial velocity over the time, which is, this one right here. That's basically your definition. So I could actually use that in one of these equations in order to solve. So that's what we're going to do. For the acceleration phase, we're going to use this second guy right here, but instead of acceleration, we're going to put in this a equals v minus v naught over t. All right? So we're going to say the distance, that's the x traveled, is equal to x naught, which of course is 0, so that's going to go away, plus v naught t, and the v naught is 0, the initial velocity is 0. All right? So we're going to be left with 1/2 times the acceleration, but the acceleration is v minus v naught over t times time squared, right? So we've been able to take out both the x naught and the v naught t because those are both 0. Now if I put the numbers in, right, I'm going to have x equals 1/2 times the final velocity. The initial velocity, remember, is 0, so that goes away. The t and one of those t's is going to cancel out. So really, all I'm left with here is v times t, which in this scenario is 3. So that's one equation right there with x and v. Okay, now I'm going to use the coasting phase, right? Now I have a lot more information in that one, all right? Still, my acceleration is going to be 0 there. That's going to help simplify things a little bit. And if this is my displacement, then again, I'm going to say the x naught is 0, right? So what I'm saying is he accelerates for this, and then he coasts for whatever's left, right? Now for that coasting, I'm going to say, well, this is x naught, and then my final position is 100 minus whatever that x was, because that x is the distance that he's not having to travel here. So I'm going to say that this x naught is 0, and that's going to allow me to say that this then is 100 minus x. All right, so we're going to go ahead and use that same equation. We're going to go x, but remember x here, that distance is 100 minus x, so we'll go 100 minus x is equal to the initial position, which is 0, plus the initial velocity. The initial velocity here is how fast he's going right now, which is the final velocity from the acceleration phase, times the time. The amount of time is 6.69 seconds. And then, of course, it's plus 1/2 at squared, but we know the acceleration is 0, so that term goes away as well. So now I've got a second equation in x and v. Since I have that, I should be able to just substitute, right, and solve for v. So here, if I simplify, I've got x equals 1.5v. So I'm going to go ahead and put that in for x over here. So I've got 100 minus 1.5v equals 6.69v. Add the 1.5 to each side. I've got 100 equals 8.19v. Divide by 8.19, and I get v equals 12.2 meters per second. That, my friends, is the maximum speed. That's v. That's what he gets to at the end of his acceleration phase. Now, it also asks for the acceleration. Well, the acceleration is going to be a little bit easier now because I have that final velocity, right? I should be able to put that in just to this first equation here and say, well, 12.2 equals the initial speed plus the acceleration times the time, which was 3 seconds. And you solve and get that the acceleration is equal to 4.07 meters per second squared. And so I've answered question A. All right, in question B, it says he set the world record in the 200-meter dash with this time using the same assumptions. What was his maximum speed for this race? All right, well, you should then be able to go through a similar process. All right, and if you go through the same process again, hopefully you'll be able to get his maximum speed in the 200-meter dash, which was 11.2 meters per second. All right, so I'm not going to work through B. I'll let you do that now that I've walked through it once for you, and hopefully you'll be able to use this same process. All right, use that V equals V naught AT, or the definition of acceleration, to plug into one of the other equations so that you don't have a present. All right, so that's it for today. I hope that was helpful, and good luck on the rest of your problems.